Hello there and welcome back to the Sleep Science, where even the tiniest raindrop can become tonight's lullaby. Picture this. You're standing just outside, maybe on a balcony or beneath a flickering streetlight, and you feel the very first drop of rain land against your skin. Cool, startling, but also oddly gentle. It doesn't arrive alone. It brings with it a universe of molecules, tiny hitchhikers and fragments of the sky's long journey. Already, without you realizing, chemistry is happening in that little splash, dissolving gases, releasing faint scents, and leaving behind a fleeting memory of the atmosphere above. You probably won't survive if you try to drink only rainwater in the modern world. It's far from as pure as poets like to say. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And I'd love to know, where are you listening from tonight and what time is it there? Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. The first drop continues its descent, and you notice the way it strikes not just your skin but also the metal railing nearby. Against metal, it splatters into a tiny starburst, quick as fireworks, while on your skin it lingers as a rounded bead. That difference itself is chemistry, water molecules clinging more tightly to themselves than to most other surfaces. The fancy word for this is cohesion, and it's why a raindrop doesn't just smear instantly into nothingness. It's the same reason you can balance a slightly overfilled glass of water without it spilling, at least until your cat decides to knock it over. In that instant, you're connected to an ancient story. For as long as humans have been around, people have been aware of the mystery of rain. Ancient Mesopotamian farmers once celebrated the arrival of seasonal downpours as divine gifts from the gods. Without them, crops withered and life ground to a halt. And yet, those same people must have noticed the practical oddities. How the first drops often carried a bit of dust. How the taste of rainwater shifted after a storm passed through. How it felt slightly different depending on where it fell. Historians still argue whether early civilizations understood the link between rain and fertility as a spiritual matter alone, or if they also began, in their own proto-scientific way, to sense that there was something in the water itself. That first drop isn't just water. By the time it reaches you, it's probably carrying dissolved carbon dioxide from the air, making it faintly acidic. Think lemon juice diluted beyond all recognition. And if you're unlucky, it may also host tiny specks of soot from passing cars or microplastics wafting invisibly through the sky. The rain is pure in poetry, messy in reality, but endlessly fascinating. Now listen more closely. The rhythm is shifting. More drops are arriving, tapping softly on the ground, on rooftops, on leaves. Each one repeats the same story, but in its own subtle variation. You hear the percussion building, a low-tempo concert. The sound of rain itself has a kind of chemistry. The way the drops strike soil releases aromatic compounds. The way water meets porous surfaces creates air bubbles that burst with faint clicks. Scientists once recorded raindrops falling into ponds and found that each bubble popping made an ultrasonic note, inaudible to humans but busy music in the underwater world. Somewhere, a fish is basically getting a secret concert every time it rains. There's also the smell. You don't notice it yet, not with the very first drop, but it's waiting to arrive. The earthy scent of Petrichor, which we'll wander into more deeply later. That smell comes alive only after more drops collide, freeing oils and microbial compounds from the soil. For now, what you smell is subtler. The sharp freshness of ozone that lightning can create, or maybe the faint dustiness of dry streets just beginning to dampen. A quirky tidbit. In the 19th century, some people believed that the first raindrops of a storm were poisonous. They thought the sky used that opening salvo to wash away its dirt and filth. and only after a few minutes did the rain become safe to collect. In a way, they weren't entirely wrong. Scientists now know that the very first rainfall often contains higher concentrations of pollutants scrubbed from the air. So yes, if you were a Victorian trying to drink fresh rain, waiting a bit was actually the smart move. And yet here you are, holding out your hand in the modern day, catching a bead of water from the atmosphere itself. It's startling to realize that the very same molecules you feel now might once have passed through the lungs of a dinosaur, or condensed in the mist above Cleopatra's Alexandria, or frozen in the glaciers of the last ice age. Rain connects past and present not in abstract poetry, but in direct chemical fact. Hydrogen and oxygen looping endlessly, reshaped but never destroyed. As you stand there, more drops gather, and you feel the shift in mood. The first one was a surprise. Now there's a steady rhythm. The air cools, the light softens, and every sense you have seems tuned to this gentle performance. You're not just watching water fall. You're sensing a molecular drama that began long before this moment and will continue long after you've gone inside to dry off. The first drop has done its job. It has woken your skin, your nose, your ears, and perhaps your curiosity. Tomorrow it may sink into the soil, roll down into a storm drain, or evaporate back into the sky. But tonight it reminds you that even the simplest act, water falling, carries within it the quiet chemistry of rain. The drops multiply, and soon you find yourself beneath a curtain of water that the sky has been preparing for hours, maybe days. You tilt your head up, eyes closed, and you can almost picture the whole process. Invisible vapor, drifting upward, cooling as it climbs higher into the troposphere. The air thins, the temperature drops, and suddenly those gas phase molecules no longer have the energy to stay independent. They huddle together, clinging through hydrogen bonds, forming the tiniest clusters of liquid. In your imagination, it's like a cosmic cocktail party where every water molecule insists on hugging 3 or 4 neighbors. But this isn't just physics, it's chemistry wrapped in motion. Those vapor molecules started their journey on warm pavement, in ocean spray, or even from the breath of animals exhaling moisture. The very air around you is a constantly shifting soup of water molecules, and when conditions are right, they surrender their freedom and condense into droplets. Historically, this idea, that clouds are made of water, wasn't always obvious. The Greek philosopher Aristotle thought clouds were just exhalations from the earth, a kind of smoky vapor rising upward. His explanation lingered for centuries because it felt intuitively true. Yet, as telescopes and thermometers entered the scene in the 17th century, scientists like René Descartes began poking at weather more seriously, and the modern understanding of condensation slowly settled in. Historians still argue whether Descartes' work on optics and halos in the sky truly counts as the first scientific meteorology, or whether it was more of a side quest in his philosophical explorations. Meanwhile, back in your mind's eye, you're floating upward with the vapor. The higher you go, the cooler it becomes until the invisible turns visible. Wisps of cloud appear delicate, silver-tipped, as if someone has painted the sky with a slow hand. Every cloud you see is made not of misty fluff, as cartoons would have you believe, but of trillions of condensed droplets, each barely large enough to scatter light. That scattering, by the way, is why clouds look white. Sunlight slams into those tiny spheres and bounces around, mixing all the wavelengths until your eyes perceive brightness. At sunset, when light comes in slanted and red-tinted, the clouds glow with fire instead. You can almost hear the molecules muttering, too cold to float free, too heavy to stay small. They cluster more and more, growing until gravity begins to whisper its claim. This is the part of the story where a single molecule's choice to join in with its neighbors becomes a raindrop's destiny. But clouds aren't just collections of water. A quirky bit of trivia: inside thunderclouds, scientists have found bacterial cells floating among the droplets, alive and apparently thriving in that frosty sky world. These microbes may even act as ice nucleating agents, kickstarting the freezing process and helping droplets grow. So the next time you see a storm cloud looming, you could think of it as part weather system, part airborne petri dish. Comforting, right? You picture yourself drifting sideways now, gliding through the belly of a great cumulus cloud. It's strangely silent, as if the sound of the rain is happening elsewhere far below. Each droplet around you is suspended in delicate balance, pushed upward by air currents just as much as it's pulled downward by gravity. Some droplets collide and merge, others shatter into mist. The chemistry is constant, each collision redistributing energy and shaping what eventually falls to Earth. You chuckle to yourself, because in a way clouds are the original group project. Every molecule joins reluctantly, contributes in its own small way, and together they create something massive, then eventually fall apart under their own weight. At least in this project, no one gets stuck doing all the work. From your balcony on the ground, you can't see this dance, but you sense it. The rain you feel has already gone through that whole life cycle: evaporation, condensation, aggregation, before choosing you as its landing pad. And yet, even as the sky pours, some clouds above you are still just carrying potential. Not every droplet will fall. Some will re-evaporate, slipping back into invisibility before they ever touch soil. The water cycle isn't just a loop, it's a gamble. As you breathe in, you realize you're also part of this process. Every exhale you make contains moisture, and under the right conditions, it could drift upward and join those high-altitude games. 1,000,000 years from now, some far-off raindrop could contain the very molecule of water you've just released tonight. The chemistry of condensation is, in the end, a story of compromise. Molecules give up their independent, speedy vapor lives to huddle together. Clouds give up their suspended beauty when droplets grow too heavy. And eventually, the sky gives up its burden, delivering rain to whatever lies beneath. Your rooftop, your garden, or that poor, unsuspecting pedestrian who left their umbrella at home. As the rain continues outside, steady now, you imagine the unseen kitchen of the sky. Steam rising invisibly, chilled in invisible layers, kneaded into droplets like dough, and then served down upon the earth. You could almost say the clouds have been baking all day, and you're the lucky guest tasting the first slice. The drops that fall on your shoulders tonight didn't just appear out of nowhere. They had to borrow a starting point, and here's the secret: water alone can't really form a raindrop in the open air. Vapor molecules desperately want to stick together, but in the wide emptiness of the sky, they need a little scaffolding. That's where dust comes in. Imagine you're a microscopic speck of pollen, drifting upward after a gust of wind shakes you free from a flower. You're weightless for a moment, carried higher than you ever thought you'd float. Around you, invisible water vapor begins to cluster, grateful for something solid to cling to. Suddenly, you're not just pollen, you're the seed of a raindrop. Scientists call these tiny helpers cloud condensation nuclei, and without them, the sky would stay stubbornly dry far longer. It's a strange partnership. Dust, smoke, ash, even microscopic salt grains from ocean spray. All of them can act as the skeleton on which water builds. In fact, after volcanic eruptions, rain often falls more quickly and heavily because the atmosphere is suddenly crowded with new nucleation points. Historical accounts tell of villages blanketed in ash that were followed almost immediately by dark, soaking rains. Historians still argue whether some of these black rains, reported after eruptions, were exaggerated for dramatic effect, or whether the chemistry truly produced inky, soot-laden storms. From the ground, you only see the results. A fat drop of water lands on your hand, cool and heavy, and you don't realize you're touching the final form of a team effort. Inside that droplet hidden is a grain so small you never spot it without a microscope, the tiny matchmaker that brought molecules together. There's a quirky tidbit about ancient Roman beliefs here. Some writers claim that the very first rains of the season carried sacred power because they were virgin drops, untouched by soil. Farmers even rushed to collect them in jars, convinced these waters had healing strength. Little did they know they were actually gathering droplets born from dust, smoke, and sometimes even airborne animal dander. So much for divine purity, though to be fair, microbes hadn't yet been invited to the conversation. As you watch the streetlight halo shimmer through the falling rain, you realize that each drop's journey is unique. Some began on wind-blown desert dust, others on soot from your city's chimneys, still others on salt from oceans thousands of miles away. A single storm can carry whispers from every corner of the globe, condensed into the bead of water sliding now down your window pane. The chemistry gets even stranger. Certain bacteria, like Pseudomonas syringae, have evolved proteins on their surfaces that make them especially good at nucleating ice. Yes, you heard that right. Living microbes hitch rides into the sky and help form raindrops, hail, and snow. Some researchers argue these organisms might even influence regional weather patterns. It's like bacteria throwing a block party in the clouds, and the result is your umbrella being tested yet again. You lean back against the railing, feeling the patter on your sleeves. The thought that every drop hides a speck, a story, a fragment of earth suspended in the air makes the whole experience richer. You're not just being rained on, you're being tapped on the shoulder by pollen grains, volcanic dust, ocean spray, even fragments of wildfire smoke. The rain is literally the sky returning what it borrowed. The next time you see sunlight streaming through your window and highlighting a floating mote of dust, you might smirk. That ordinary speck, if lifted high enough, could someday return as rain on your skin. Dust to dust, as the old saying goes, but also dust to drizzle. And in the growing downpour outside, you realize the rain isn't just falling randomly. It's falling with a hidden structure, each droplet carrying an anchor from somewhere else, a microscopic passport stamped with its origin. Tonight, you are being showered by an archive of the earth itself. The rain builds heavier now, and though your ears register only the soothing hiss, the sky is sparking with invisible drama. Every storm carries its secret electrician, static charges building, molecules colliding, whole clouds rubbing against themselves until the tension becomes unbearable. You tilt your head upward, and even without a flash, you sense it, electricity crackling in the damp air above. Inside those clouds, droplets and ice crystals are jostling, bumping into one another like restless commuters. Each collision transfers charge, separating positives and negatives until one region of the cloud becomes desperate for balance. That imbalance is lightning's cue. A single bolt is hot enough to outshine the sun's surface for a fraction of a second, and when it rips through the sky, it doesn't just put on a light show, it rewires the chemistry of rain. Here's the neat trick. When lightning strikes, the air around it becomes so energized that nitrogen and oxygen atoms split and recombine into new forms, including nitric oxide. Those molecules dissolve into rain, turning each drop into a faint delivery system of natural fertilizer. Farmers centuries ago may not have known the word nitrate, but they noticed fields often thrived after storms. Historians still argue whether early agricultural societies linked thunder with fertility rituals for spiritual reasons only, or whether they dimly sensed that storms literally fed the soil. From where you stand now, you breathe in that sharp tang of ozone, the 3-oxygen cousin of the air you normally inhale. That's another byproduct of lightning drifting down toward you. The smell is crisp, metallic, almost like the faint zing of a photocopier, except here it's the sky doing the printing. You laugh softly. Imagine Mother Nature running her own copy machine across the heavens. A quirky tidbit. In the 18th century, Benjamin Franklin not only flew his famous kite, but also experimented with capturing storm water, convinced that electrified rain held unique properties. He wasn't entirely wrong. Ionized particles formed by lightning do change the chemical cocktail inside those droplets, though probably not in the liquid lightning potion sense he hoped for. You feel the drops against your arms, and suddenly you imagine them as tiny batteries. Each has been brushed by an atmosphere that moments ago carried millions of volts. No, you won't get shocked by catching rain on your tongue, but the molecules are altered, rearranged, made just a little different by the storm's electric theater. And yet the rain itself remains calming. It's a funny contradiction. Above you, forces so violent they split atoms. Around you, a lullaby of falling water. You can't reconcile the chaos with the peace, so you don't try. Instead, you stand in both truths at once. Thunderclouds as roaring laboratories, raindrops as soothing messengers. In your mind's eye, you picture the streak of a lightning bolt, blinding and branching, a jagged artery connecting cloud to ground. Along its path, molecules have been blasted apart and stitched into new forms. When those altered gases dissolve into rain, they're carried down to earth, feeding roots, seeping into rivers, slipping quietly into the ocean. Every storm is a giant, unsupervised chemistry experiment, and you're catching its results on your sleeve. Of course, not everyone through history greeted lightning with curiosity. Many cultures feared it, believed it was the anger of God striking down. The Norse saw Thor hurling his hammer, the Greeks, Zeus casting his bolts. Yet even amid the myths, there's a thread of reverence. Storms brought both destruction and renewal. The duality of rain charged with fire from the sky wasn't lost on them, and in some ways you feel it too tonight. Another drop hits your lip, cool and metallic. You taste a faint difference from ordinary water, though you probably wouldn't describe it as delicious. Still, knowing that this very droplet may carry the chemistry of a lightning bolt makes it extraordinary. It's like sipping from the edge of the universe's energy. So you stand, damp but entranced, aware that every flash and rumble overhead is not only reshaping the atmosphere but also seasoning the rain that soothes you. In storms, the sky doesn't just pour, it reacts, reforms, and delivers new life molecule by molecule. The rhythm of the storm begins to settle now, no longer as violent, and with it comes a familiar perfume. You inhale deeply, and there it is, that earthy, almost nostalgic smell people recognize instantly after rain touches dry ground. It has a name, one as soft on the tongue as the aroma itself, Petrichor. It doesn't come from nowhere. The secret lies in the soil, where microscopic life has been working quietly for millennia. Certain bacteria, especially actinobacteria, produce a compound called geosmin as they go about their business. When raindrops strike the ground, the impact launches tiny bubbles of air laced with geosmin into the atmosphere. They pop, releasing that unmistakable fragrance. You're literally smelling bacterial handiwork with every breath of post-rain air. Delicious, right? A perfume made by microbes. This isn't just speculation. In the 1960s, Australian scientists Isabel Baer and Richard Thomas first coined the word petrichor to describe the phenomenon. They noticed how oils exuded by plants during dry spells combined with bacterial compounds, creating a scent only released when rain returned. Historians still argue whether cultures in antiquity ever gave this smell a name, but writings from ancient India describing the earth's breath after monsoons hint that the recognition is timeless, even if the science is modern. You lean against the damp railing and notice how the smell grows stronger with the storm's intensity. A quirky tidbit: camels are said to be able to detect the scent of rain on the wind from over 50 miles away, an evolutionary trick to find oases. Imagine a caravan in the desert, noses twitching not at water they can see, but at geosmin molecules floating invisibly ahead of the clouds. Tonight, your own nose is doing a much smaller version of that desert survival test. Every drop hitting the ground is an alchemist, releasing tiny bursts of air, spraying microscopic oils into your path. The chemistry is so efficient that the smell can precede the storm itself. On some summer afternoons, you've probably noticed the scent of rain drifting in before the clouds break. That's not your imagination. It's the earth hinting at what's about to arrive. You breathe again, deeper, and feel the way memory tangles with chemistry. Petrichor often drags up forgotten moments: childhood summers, muddy gardens, walks home after school. Scientists think our noses are especially sensitive to geosmin because of evolutionary pressure. Even in vanishingly small concentrations, humans detect it more readily than many other odors. Some argue this helped our ancestors find fresh water sources. Others point out the irony that we also dislike the taste of geosmin when it contaminates drinking water. A smell we love becomes a flavor we reject. Our tongues are pickier than our noses. As you stand there, lulled by the patter, you picture the soil beneath your feet as a hidden laboratory. Countless microbes, invisible but tireless, each leaving their aromatic calling card. Plants, too, join the mix, releasing oils to slow seed germination during droughts, only to have those oils washed free by rain. Together, they compose the orchestra of Petrichor. It makes you smile. The earth is basically spraying its own cologne after a long, dry spell. A little dramatic, perhaps, but effective. One drop, one bubble, one scent molecule at a time, until the whole neighborhood smells freshly laundered by nature. And isn't it funny? What poets write about as the scent of rain isn't rain at all. It's soil, bacteria, and plants sending airborne signatures the moment raindrops arrive. Rainwater itself is nearly odorless, but add Earth's chemistry, and suddenly it becomes unforgettable. The storm outside has calmed into steady drizzle, and the smell now feels like a blanket, warm even as the air cools. Every breath you take carries geosmin into your lungs, binding molecules to receptors that your brain insists on translating into memory and comfort. You're not just breathing, you're time traveling through every rainy day you've ever known. The drizzle keeps falling, gentle enough that you can listen without distraction, and with it comes another secret of rain, fertilizer from the sky itself. You may have heard the phrase, storms feed the soil, and though it sounds poetic, it's also literal chemistry. Each flash of lightning you glimpsed earlier rewrote the atmosphere, splitting nitrogen molecules apart and forging them into new compounds. Those compounds hitch rides down to Earth on raindrops, like free samples in a celestial delivery service. Nitrogen is everywhere, almost 80% of the air you're breathing right now, but in its paired-up form, and too, it's stubborn and nearly useless to plants. They can't crack it open themselves. Lightning, though, has no trouble tearing it apart. When the atmosphere combusts with that energy, nitrogen atoms bond with oxygen, forming nitric oxide and nitrogen dioxide. These dissolve into rainwater, eventually becoming nitrates, a form plants can actually sip up through their roots. It's wild to think. The carrots in your soup, the wheat in your bread, even the cotton in your shirt might have grown a little taller thanks to the chemistry of distant storms. Farmers have noticed for centuries that crops often look fresher after a thunderstorm. Some even swore their fields greened overnight after heavy lightning. Historians still argue whether ancient civilizations, like the Mayans, who linked thunder gods to agricultural fertility, were responding purely to mythology or whether they sensed, in some unspoken way, the nitrogen gift hidden in rain. You tilt your head back, feel another drop land on your forehead, and picture it as a capsule of nutrients, no bigger than a pinhead yet powerful enough to shift ecosystems. Soil organisms will greet it eagerly, passing the nitrates along, trading and transforming until roots absorb them. It's a vast underground economy fueled by skyfare. A quirky tidbit: in the early 20th century, before the Haber-Bosch process industrialized fertilizer, some chemists seriously proposed building massive electric arcs to simulate lightning and harvest nitrates from the air. It was basically, let's build our own thunderstorm in a box. The plan worked on a small scale but consumed ridiculous amounts of energy. Nature, of course, does it effortlessly and without charging us for electricity. You notice how quiet the world feels under drizzle, as if even the trees are listening. Maybe they are. Each leaf dripping tonight is connected to roots already waiting for nutrients. The system is elegant. Lightning splits the sky, rain carries the altered molecules down, and plants turn them into life. Without it, many ecosystems would struggle, especially before humans learned to synthesize fertilizers. You smile at the irony. We spend fortunes on bags of fertilizer, hauling them in trucks, scattering them across fields, while the sky still provides its own, quietly and freely during every thunderstorm. Granted, nature's generosity is uneven. Some regions get more of these nitrogen-rich rains than others, but the principle is the same. Life depends on these chemical gifts. The drizzle now feels different on your skin, like you're brushing against an invisible chain of connections. Lightning, chemistry, soil, roots, food, breath. You imagine a single nitrate ion made aloft in the violence of a storm, drifting into your garden soil tomorrow, entering a tomato plant, ripening a fruit that you'll one day slice into a salad. That bite of tomato will carry a fragment of tonight's storm. And that's the quiet magic of rain. It doesn't just quench thirst, it nourishes the very cycles that feed you. You can almost hear the soil humming in anticipation, grateful for every electrified drop. The rain tonight has shifted, heavier again, but there's a subtle sharpness in the air that isn't so comforting. You breathe in, and alongside that earthy petrichor, there's a faint sting, almost metallic. Not every storm delivers nutrients, some deliver warnings. Welcome to the quiet menace of acid rain. You've probably heard the term before, maybe in a classroom or on a worried news segment from the 1980s. But in reality, acid rain isn't about some sizzling liquid that melts statues overnight. It's just ordinary rain with chemistry slightly tilted in the wrong direction. Pure water is neutral, balanced at a pH of 7. Add a little dissolved carbon dioxide from the air, and rain naturally leans slightly acidic, maybe 5.5 on the scale. That's normal. What turns it into acid rain is when extra sulfur dioxide or nitrogen oxides enter the mix. Most of those gases come from burning coal, oil, and industrial fuels. They hitchhike into the sky, meet raindrops, and dissolve to form sulfuric and nitric acids. Now, every drop falling on your skin tonight carries a bit more bite than nature intended. You probably won't feel it on your hand, but forests, lakes, and buildings certainly notice over time. History gives us vivid examples. In the mid-20th century, Scandinavia's pristine lakes suddenly lost their fish populations. Scientists eventually traced the cause back to British coal plants hundreds of miles away. Winds carried the gases, rains carried the acids, and ecosystems far removed from smokestacks suffered. Historians still argue whether political pressure from those cross-border effects was the turning point that finally pushed European countries to adopt cleaner energy policies. You glance at a stone statue in a nearby park, rain streaking down its weathered surface. Marble, limestone, even concrete, All are vulnerable. Acid rain reacts with the calcium carbonate in stone, slowly etching details away. That's why so many historic buildings in industrial cities look prematurely worn. Their carvings softened, their inscriptions fading like forgotten whispers. Imagine a cathedral standing for centuries, only to have its gargoyles erased by chemistry invisible to the eye. A quirky tidbit. In the 17th century, a British scientist named John Evelyn complained that London's smoky showers were damaging his garden plants. He didn't know the phrase acid rain, but he noticed his roses yellowing after storms. He wasn't exaggerating. Industrial air had already begun to tweak the chemistry of precipitation. You stand there now, hand outstretched, imagining each droplet as a tiny lab experiment. Some carry only dissolved oxygen and carbon dioxide. Others, depending on where the wind has blown pollutants, may host sulfur compounds strong enough to scar a forest. It's unsettling, isn't it? Something so gentle to the senses can quietly reshape landscapes over decades. And yet the story isn't all grim. Acid rain led to some of the first international environmental agreements. Governments realized they couldn't solve it alone. Pollution crossed borders as easily as clouds did. Power plants were retrofitted with scrubbers, fuels became cleaner, and in many regions, acidity levels in rainfall have since declined. The sky learned, in a way, to calm itself again. Tonight, though, you stand under the downpour aware of both sides. Rain as nourishment, rain as corrosion. The same chemistry that feeds your garden tomato could also gnaw away at the stone of a centuries-old cathedral. It's a delicate balance, hidden in every droplet. You breathe again, faintly smelling that tang, and feel grateful for the reminder. Rain is never just water. It's a mirror of the air it fell through. And sometimes, the mirror shows us the consequences of our own choices. The storm outside steadies into a rhythm now, and as drops spatter against your skin, you can't help but wonder, what exactly is inside each of these tiny messengers? Because if you think raindrops are just pure H2O, well, brace yourself. Every droplet is a little suitcase packed with souvenirs from its journey through the atmosphere. First, there are the dissolved gases. Oxygen, carbon dioxide, nitrogen, all slip into rain as it falls. That's why freshly collected rainwater tastes a little different from distilled water. Sometimes, depending on where the storm traveled, there may even be traces of sulfur dioxide or ammonia tucked inside. You're essentially drinking a condensed sample of the sky, should you dare to tilt your head back. Then come the salts. Especially near coastlines, raindrops often pick up sodium chloride from sea spray, sprinkling a little ocean into inland soils. Farmers in medieval times noticed crops near the shore seemed oddly tolerant of salt after rainstorms, though historians still argue whether they truly connected that to marine aerosols or just chalked it up to coastal magic. Either way, the chemistry was already at work, drop by drop. And here, where things get stranger, microbes can travel inside raindrops too. Tiny spores, bits of algae, even bacteria ride them down from the sky. Scientists sampling rainwater in different parts of the world have found entire communities living in each storm. It's a quirky but true detail. The next time you walk through drizzle, you're sharing the moment with microscopic stowaways. Some are harmless, some might seed new colonies in soil, and some may even influence the next cloud that forms. You picture it now, a raindrop forming around a speck of dust, then dissolving gases, grabbing ions, maybe sweeping up a wandering bacterium on the way down. By the time it reaches your hand, it's a capsule of Earth's atmosphere, chemistry, and biology all in one. If only you had a pocket microscope to check, it'd be like opening a surprise bag every second. You chuckle because in truth, scientists do exactly that. They collect rainwater in sterile glass funnels, whisk it to labs, and run it through mass spectrometers. Each sample becomes a data-rich map of what the atmosphere carried that day. Sometimes they find unexpected signatures, like pesticides drifting hundreds of miles from their source, or trace metals from industrial smokestacks across oceans. The rain tattles in its own quiet way about human activity. A quirky historical tidbit. In the 19th century, some physicians believed rainwater was the purest drink and recommended it as a health tonic. People placed barrels outside to collect it, proudly sipping the sky. Little did they know they were also drinking dissolved soot from coal fires, hitchhiking microbes, and maybe even the chemical fingerprints of faraway volcanoes. Pure, not exactly. As you watch drops racing each other down your window pane, you realize every streak is a record of movement, chemistry, and chance. One might carry Sahara dust, blown across oceans before falling here. Another might host an algal spore destined to germinate in a new puddle. The variety is infinite, and yet to your senses, it all looks like the same clear liquid. You exhale slowly, enjoying the thought. Raindrops are like tiny biographies, condensed and thrown back to Earth. Each tells a story you'll never fully know, but for a fleeting second, you're in contact with it, skin to droplet, human to atmosphere. The drizzle continues, and now the sound feels even richer. It's not just rain tapping on roofs and leaves. It's countless tiny packages, each bringing fragments of the sky to the ground. You stand there, amused, because suddenly you feel less like you're getting wet and more like you're receiving postcards from the universe. The downpour slackens, and puddles begin to collect in the streetlight's glow. You notice one forming by the curb, its surface trembling with ripples as fresh drops fall. Then you spot it, a thin, iridescent sheen stretching across the water, shifting colors like oil brushed on glass. It's the kind of rainbow puddle you've probably seen in parking lots after rain, mesmerizing in its strange beauty. This shimmer isn't magic, though it feels like it. It's physics and chemistry conspiring in plain sight. A film only a few micrometers thick, oil, fuel residue, or sometimes just organic compounds leached from leaves, rests on the puddle's surface. When light strikes it, some rays reflect off the top of the film, while others pass through and bounce back from the water underneath. The two reflections overlap, interfering with each other. Depending on the thickness of the film and the wavelength of light, certain colors cancel out while others blaze forth. That's why you see blues, greens, and purples dancing across such an ordinary patch of water. Of course, nature has been playing with thin film interference long before humans spilled fuel on asphalt. Think of soap bubbles, dragonfly wings, or even the inner shimmer of seashells. All owe their rainbow hues to the same principle. Rain just happens to provide a stage where oil slicks and light combine into accidental art. Historically, city dwellers weren't always so charmed. In the 19th century, as coal tar and horse-drawn traffic left residues on cobblestones, colorful puddles became a familiar sight. Writers occasionally described them with disgust, calling them poisoned mirrors. Historians still argue whether early environmentalists truly recognized the pollution in those sheens, or if they were more concerned with the mess on their boots. You crouch slightly to look closer, half tempted to dip a finger in, though you don't. The colors swirl with each ripple, never fixed, always changing as the surface trembles. You laugh softly, nature's version of a screensaver. A quirky tidbit. Some engineers today actually study these puddle rainbows to design sensors. Because the colors change with film thickness, they can serve as simple indicators of contamination. So yes, that parking lot puddle might be ugly to your shoes, but to a scientist, it's a diagnostic tool. The next drop splashes into the puddle, fracturing the rainbow for an instant, then letting it reform. You realize each raindrop is participating too, spreading the thin film, shifting the colors, rearranging the canvas. Rain isn't just falling on the surface, it's painting with it. Beyond oil slicks, rain also toys with light in subtler ways. Have you noticed how wet pavement glows brighter under street lamps? That sheen comes from the smooth water layer, which reflects light more evenly than rough, dry asphalt. In a way, the whole city becomes a giant reflector, doubling the glow, making nighttime rain walks feel cinematic. You step back, letting your gaze drift upward again, but the puddle lingers in your mind. The rainbow film may be fleeting, vanishing once the water drains away, yet for now it feels like the street has been dressed in jewels. It's a reminder that even the residue of daily life, oil, dust, and dirt, can be transformed by rain into something briefly wondrous. And isn't that a comforting thought? Tonight, the storm didn't just wash the world. It gave you a puddle rainbow, a tiny chemical kaleidoscope at your feet. The puddle rainbow fades as the water drains away, but your thoughts wander upward, past the wet streets and flickering lamps, into the long history of how humans have looked at rain. For you, it's science and comfort. For ancient cultures, it was nothing short of divine chemistry, water falling from the heavens as a message, a blessing, sometimes a threat. You picture yourself in Mesopotamia thousands of years ago, standing in the baked clay fields between the Tigris and Euphrates. When the first drops finally hit the ground after months of heat, farmers looked upward in awe. They credited their storm gods, Adad or Ishkur, with choosing when and where to send water. The chemistry of nitrates and microbes was unknown, but the outcome was clear. No rain, no crops, no survival. Historians still argue whether those earliest myths were born purely from fear of drought, or if people already noticed subtle links between rain and soil fertility. Shift scenes to ancient Egypt. The Nile's floods were the great provider, but rainfall itself was rare, almost exotic. So when it came, some texts describe it as the tears of Isis falling upon the land. Imagine believing that the drop landing on your forehead tonight was part of a goddess's grief, a sacred molecule of sorrow. A quirky tidbit: the Aztecs believed their rain god, Tlaloc, demanded child sacrifices to ensure storms. Archaeologists uncovered small figurines buried in watery temples, their wide eyes echoing the desperation for rain. Morbid as it sounds, it reveals how central rainfall was to survival. Without those showers, entire empires withered. You stand beneath your own drizzle, safe from such rituals, but still aware of the awe that rain inspires. Myths across the world often painted raindrops as divine messengers. Zeus hurling storms in Greece, Indra releasing monsoons in India, Thor thundering with rain-laced hammer blows in Scandinavia. Different pantheons, same principle. Sky water wasn't just weather, it was power descending to earth. And yet, not all rain myths were fearsome. In some Native American traditions, the first drops of spring were greeted with songs, seen as gifts rather than threats. In Japan, Shinto rituals celebrated Aim no Minakanashi, a deity tied to rainfall and creation itself. The world's oldest cultures wove rain into origin stories, treating the chemistry of condensation as sacred design. You imagine yourself under those skis, no umbrella in hand, just a human in a vast world depending on the mercy of clouds. Tonight, with your modern streetlights and warm apartment waiting, you feel that same thread of dependence, maybe less desperate but still real. Rain is both familiar and mysterious, its chemistry explaining the how, but not always tamming the awe. The drizzle on your skin is suddenly more than just weather. It's a continuation of belief, myth, and reverence that stretches back millennia. You don't need to see gods in the clouds to understand why they were imagined there. When water falls from a blank sky, carrying invisible nutrients, scents, and even microbes, it still feels like a miracle. The rain outside softens now, the storm's sharpness fading into a calmer rhythm. It makes you think of another thread that has always run alongside rainfall, our determination to catch it, to save it, to make it ours. From clay jars on ancient rooftops to modern gutters and tanks, people have harvested rainwater as long as they've been able to tilt a vessel upward. You picture yourself back in Bronze Age India, standing among stepwells, intricate staircases carved deep into the earth, leading down to vast cisterns. When the monsoon clouds finally emptied themselves, those wells filled like treasure chests. Families descended the steps to scoop water, grateful for the chemistry that kept them alive through dry seasons. Historians still argue whether the earliest stepwells were purely practical, or whether they doubled as ceremonial sites, given how often they appear in religious texts. Shift again. Now you're in ancient Rome, where rooftop channels funneled rainfall into giant underground cisterns. Wealthy households prized rainwater for its softness, free of the minerals that made well water taste harsh. A quirky tidbit, Roman laundries or Phalaniki actually preferred rainwater for washing togas because it mixed better with their rather unappealing detergent of choice, fermented urine. Suddenly, that amphora of pure, sky water doesn't sound so elegant. Tonight, you listen to the rain tick on your window and imagine a jar sitting outside. Even now, modern rainwater harvesting follows the same principles: collect, funnel, store. In rural parts of the world, it remains a vital lifeline. Rooftops slope toward gutters, pipes carry the water into tanks, and filters strain away debris. One good storm can fill barrels enough to irrigate gardens for weeks. But as always, the chemistry complicates things. Rainwater absorbs whatever it passes through. In industrial cities, that might mean traces of lead or soot, near oceans, salts, downwind of farmland, even pesticides. Collecting rain isn't as simple as bottling purity. It's bottling whatever the sky has mixed into its recipe. And yet the appeal never fades. There's something magical about drinking from the sky, about holding in your hands a liquid that fell moments ago from clouds you could still point to. Even with filters and modern caution, people describe the taste of fresh rainwater as softer, smoother, almost sweeter. Perhaps it's psychological, perhaps it's chemistry, but the sense of connection is undeniable. You imagine a barrel outside your window tonight, slowly filling drop by drop. Each ping of water against the lid is a record of time, a signal that the storm is gifting you something tangible. Rain no longer feels abstract. It becomes storage, sustenance, future. It's funny, though. For thousands of years, civilizations engineered canals, cisterns, aqueducts, all to control what falls so freely from the sky. Tonight, as you listen, you realize how little has changed. We're still catching droplets in jars, still hoping storms arrive on time, still looking upward with gratitude when they do. The barrel you imagined filling outside your window is almost brimming now in your mind's eye. But here, the question people have always asked, is this rainwater healing or hazardous? The answer, inconveniently, has always been both. Picture yourself in medieval Europe. Folk healers often prescribed rainwater as a cure for skin ailments or as a rinse for hair. Some even claimed the first rain of May had special powers, cleansing the body of sickness if you washed in it at dawn. Historians still argue whether these rituals were born from genuine observation, since fresh rainwater does feel softer and cleaner than well water, or whether it was just seasonal optimism wrapped in superstition. Now shift to Victorian England, where households proudly collected rainwater for drinking. It seemed logical. Water falling from the sky must be pure, right? A quirky tidbit. Some families even kept decorative rain jars in their parlors, boasting that they served only sky water to guests. Unfortunately, their charming beverage often contained soot from coal chimneys, bacteria from bird droppings on rooftops, and whatever else the air decided to contribute. The chemistry was less elixir of the heavens and more mystery soup. Tonight, as you lean against the damp window frame, you imagine dipping a glass into that barrel outside. The water looks pristine, glittering with drops still falling from the sky. Yet unseen within it could be microplastics, airborne pollutants, or microbial spores. You laugh softly. Nothing says cheers like a microscopic party you didn't invite. And yet, you can't deny the healing side. Rainwater is soft, meaning it contains very few dissolved minerals like calcium or magnesium. That makes it ideal for washing clothes, for rinsing hair, even for watering delicate plants that dislike hard tap water. Many gardeners today still swear their plants perk up after rain, not just from hydration, but from the unique chemistry of what falls. In some cultures, rituals around rainwater were less about medicine and more about magic. In parts of Africa, elders collected the first rain of the season in gourds, using it in blessings and ceremonies. The symbolism was clear. What came from the sky carried purity, renewal, and a touch of divine favor. Whether or not the water itself was clean by laboratory standards didn't matter. It was clean in the heart. You tilt your head, watching drops streak the glass, and you realize rain has always been a paradox. To some, it's medicine. To others, it's poison. Science now tells us both are true, depending on what the storm swept up. But as you listen to the rhythm outside, you also understand why people kept taking the risk. There's a romance in catching the sky itself, in believing you can sip from the clouds. So tonight, whether healing or hazard, the water falling beyond your window reminds you of this. Every drop carries both promise and peril, purity and pollution, blessing and warning. And that duality is part of its quiet allure. The rain outside steadies into a nourishing rhythm, and with it comes a reminder. Every farmer in history has depended on this chemistry. It's not just water soaking the soil. It's a mixture of nutrients, gases, and minerals that shape how crops grow. Tonight, as you listen to the drops, you can almost feel the fields leaning upward in gratitude. Think of a wheat field after a storm. The raindrops don't just quench thirst. They deliver nitrogen compounds formed by lightning, trace minerals swept from the ocean, even faint dust particles carrying phosphorus from deserts thousands of miles away. Plants sip all of it, not just the water, weaving it into grains that will later become bread. Without this chemical cocktail, agriculture would collapse. History bears that out. Ancient Chinese farmers carefully tracked rainfall, knowing monsoon timing determined rice harvests. In Egypt, records carved into stone described years of plenty and years of famine, each tied to water or its absence. Historians still argue whether early dynasties fell primarily because of political weakness or because droughts undercut their food supply. Either way, rain's chemistry held empires in its grip. You shift your gaze to the nearest tree, its leaves trembling under droplets. Even in your urban setting, you can sense the same truth. Plants depend on storms. The chemistry in those drops feeds chlorophyll, fuels growth, and indirectly feeds you too. That tomato on your plate, its flavor is, in part, the echo of rainfall. Here's a quirky tidbit. In the Dust Bowl era of the 1930s, desperate farmers sometimes believed rain follows the plow, that breaking the soil itself would somehow summon storms. Of course, it didn't. The climate had turned and the rains withheld their gifts. Yet the belief shows how entwined rain and farming have always been in the human mind. Tonight's drizzle seems gentler now, and you imagine farmers across centuries listening to the same sound, praying for just enough. Too little and crops wither. Too much and fields flood. It's a balancing act that no farmer can truly control, only endure. As you breathe in the earthy smell, you feel a connection stretching across time, from ancient rice paddies to modern cornfields, from steppe grasslands to backyard gardens. Rain doesn't just feed plants, it feeds civilization itself. And every drop outside your window tonight is part of that endless contract. The storm drifts deeper into the city now, and you notice the way rain reshapes the landscape, not in forests or fields, but across concrete and copper. Urban rain is a chemist with strange tools. Each drop that splashes onto a rooftop or rushes into a gutter is already starting to react with the world humans have built. You glance at the brick wall across the street. Water runs down in streaks, darkening the surface, leaching minerals that slowly leave behind faint chalky stains. On copper gutters, the effect is even more dramatic. Rain reacts with the metal, forming green patinas of copper carbonate. That familiar turquoise color on old rooftops or statues. It's chemistry carved by centuries of storms. The Statue of Liberty herself owes her iconic hue to rain's patient brushstrokes. Historians still argue whether engineers foresaw this transformation or simply accepted it as a happy accident. Concrete sidewalks, too, show rain's handiwork. When water seeps in, it dissolves tiny bits of lime and carries them back to the surface. As the water evaporates, the lime recrystallizes into pale, powdery streaks called efflorescence. A quirky tidbit: medieval masons sometimes viewed these streaks as signs that a building was breathing properly, proof that water wasn't trapped inside the stone. Today, we mostly see them as cosmetic nuisances. You look toward the street where rainwater swirls into drains. On the way, it lifts oil slicks from cars, fragments of rubber from tires, even microscopic shavings of metal. The city is full of hidden chemistry, and rain acts as both broom and solvent, carrying debris into sewers, then rivers, then oceans. Each storm turns the streets into temporary rivers of reaction. And then there's acid rain again, harsher in cities. Here, droplets scrub pollutants from smokestacks and exhaust pipes, making the water that falls more aggressive. Marble monuments soften, iron fences rust, and painted walls peel. Rain becomes both sculptor and saboteur, eroding what we build almost as quickly as we can replace it. You laugh softly, imagining the city as a giant open-air laboratory. Rain drips down power lines, reacts with zinc coatings, corrodes joints, and leaves rainbow streaks on asphalt. If you were a chemist with infinite patience, you could study a single city storm and write a textbook from its experiments. But it's not all decay. Sometimes the reactions create beauty. Rust on bridges turns deep orange, streaking like abstract art. Old copper roofs glow green under the drizzle. Even puddle reflections double the neon lights of the city, as if rain wants to dress the streets in color rather than ruin. As you listen, you realize that urban rain is different from rural rain, not in essence but in story. In the countryside, it feeds soil and crops. In the city, it etches, corrodes, polishes, and reveals. Tonight's downpour is quietly reshaping every rooftop, every lamppost, every forgotten pipe. And tomorrow, the evidence will remain: streaks, stains, patinas, proof that the chemistry of rain never sleeps. The city quiets behind you as your thoughts drift farther outward toward the sea, where rain meets its vastest partner. Imagine standing at the shoreline tonight, waves restless under gray skis, raindrops piercing the surface with countless tiny dimples. The chemistry here is different, subtle yet profound. Each drop of fresh water is stepping into a salty kingdom, and the clash changes both sides. Rain is soft, carrying very few dissolved minerals. When it falls onto the ocean, it briefly dilutes the salinity at the surface. That thin layer of fresher water can matter more than you'd expect. Tiny plankton living in the top few centimeters suddenly find their environment altered. pH shifts, salt balances tip, and their delicate membranes respond. A single storm may feed or stress entire blooms of microscopic life. It's humbling to realize, without these plankton, there's no oxygen for you to breathe. They produce half of the oxygen on Earth, and rain plays a quiet part in nudging their chemistry. Historians still argue whether early sailors noticed these subtle changes. Did they sense calmer seas after heavy rain because of surface dilution? Or was it just the weight of water tamping down waves? The evidence is murky, but the question lingers. Another effect: rainwater carries dust and nutrients from land to sea. Iron particles swept from deserts, nitrogen compounds forged by lightning, even soot from factories, all hitch rides in droplets, eventually landing in the ocean. There they can spark plankton blooms. Some researchers call storms nutrient delivery systems for marine ecosystems. You picture a droplet landing tonight, dissolving and fueling a chain reaction that ends with a school of fish thriving weeks later. A quirky tidbit: in Polynesian navigation traditions, skilled sailors sometimes claim to taste the rain on the ocean's surface, distinguishing freshening patches from saltier waters. While it sounds legendary, modern oceanographers note that rain really can create subtle surface layers detectable by taste, at least for a short time before currents mix it away. Standing in your imagination at the shore, you feel the duality. Rain can soothe the ocean, layering it with fleeting freshness, but it also delivers pollutants, mercury, pesticides, microplastics, that rivers and winds have already tossed skyward. Every drop carries both gift and burden. Back at your window, the city storm feels smaller in comparison. Yet you know each drop outside may eventually join a river, then the ocean, continuing the exchange. Rain never falls in isolation. It's always part of a grander cycle, tying your balcony tonight to plankton blooms thousands of miles away. The chemistry is endless. Hydrogen bonds, salt balances, nutrient transfers, pH shifts. But the feeling is simple. Rain on the ocean is one of Earth's quiet negotiations, balancing life molecule by molecule. And tonight, you're a witness to one tiny corner of that global dialogue. The storm's rhythm above ground fades in your ears, and your mind begins to follow the water downward, past sidewalks, past roots, past layers of stone, into caverns where raindrops write their slow, secret poetry. Down here, the chemistry is quieter still, but it leaves its mark in stone that lasts millennia. Picture yourself in a limestone cave. It's utterly dark except for the glisten of droplets forming at the ceiling. One gathers slowly, swells, then finally lets go. When it falls, it strikes the cave floor with the faintest plink, adding to a puddle that will, over centuries, sculpt entire landscapes underground. Here's the trick: rainwater isn't just water anymore. As it passes through soil, it picks up carbon dioxide from decaying plants and roots, forming a weak carbonic acid, harmless to your skin but persistent against stone. As the drops seep into limestone, they dissolve a little of the rock, carrying calcium carbonate in invisible solution. When the water re-emerges inside the cave and drips into the open air, carbon dioxide escapes again, and the dissolved minerals re-solidify. Slowly, patiently, the drop leaves behind a tiny ring of calcite. Thousands of years later, you have a stalactite hanging above your head, or a stalagmite rising beneath it. It's absurdly slow work. Stalactites grow less than 10 centimeters every 1,000 years. You joke to yourself that they'd never win a speed-building contest unless they were competing against glaciers. And yet, their patience is unmatched. Historians still argue whether early cave dwellers noticed this growth at all. Did they believe the stone icicles were alive, dripping into existence? Some European folklore suggests stalactites were thought to be frozen moonlight, solid beams dripping from the heavens. Science eventually revealed the chemistry, but the magic remains in the waiting. A quirky tidbit: in some caves, the mineral-rich drops don't just build rock, they sing. When water strikes hollow formations or pools, it produces tones, each drip a note in a natural instrument. Explorers have nicknamed certain caverns singing caves, and modern acousticians sometimes record their drip scores. So yes, rain underground doubles as both sculptor and musician. As you listen to the storm outside your window, you imagine its droplets splitting paths, some feeding rivers, some evaporating skyward, and some slipping silently underground to carve monuments in the dark. Your balcony feels small, but you're suddenly connected to caverns that will be shimmering long after your own time. Each drip down there is a geologist's diary entry. Each trace of calcite records a rainfall, a season, even ancient climates. Modern scientists study stalagmites like tree rings, decoding past droughts and storms locked inside their layers. So when you watch rain tonight, you're also watching tomorrow's data for future archaeologists, droplets as archivists of time. You exhale almost in reverence. Rain above ground is fleeting, a passing comfort. Underground, it is eternal, writing in stone with the softest pen imaginable. The rain tonight grows colder, and you imagine what happens when those droplets take on harder, sharper forms. Not all precipitation arrives as gentle beads of water. Sometimes the sky decides to remix its chemistry into sleet, hail, or snow, icy cousins of rain with quirks of their own. You tilt your hand outward and picture a sleet pellet bouncing against your palm. Unlike rain, which falls in smooth arcs, sleet clatters, half liquid, half solid. It forms when droplets pass through a freezing layer of air on their way down, solidifying into tiny ice bullets. Annoying to walk through, but fascinating to consider. Each one carries the same dissolved gases and dust nuclei as raindrops, just locked into crystalline cages. Hail is another story altogether, bigger, bolder, and almost theatrical. Inside thunderclouds, updrafts hurl droplets upward again and again, layering ice around them like onions. The longer they're tossed, the larger they grow until gravity finally wins. Some hailstones crack open like jawbreakers, revealing rings that map their stormy journeys. Historians still argue whether the giant hail described in medieval chronicles, stones the size of goose eggs, was exaggerated folklore or genuine meteorological events. Modern records prove such sizes are possible, though hopefully not on your balcony tonight. Snow, of course, is the most delicate of the trio. Each flake begins as the same condensation nucleus as rain, but in subfreezing air, water vapor crystallizes directly into ice, forming those intricate six-sided patterns. You smile at the cliché that no two snowflakes are alike. Chemically, they're all just H2O, but structurally, each one takes a unique path through shifting temperatures and humidity. A quirky tidbit: in the 19th century, a Vermont farmer nicknamed Snowflake Bentley devoted his life to photographing snow crystals, proving their diversity long before digital cameras. His neighbors thought he was eccentric, but his obsession helped launch the science of ice morphology. You imagine standing in a quiet snowfall, each flake drifting gently, carrying within it not just frozen water, but also the same invisible hitchhikers as rain, dust, spores, even trace pollutants. In polar ice cores, scientists still find layers marked by volcanic ash or atmospheric chemistry from thousands of years ago, frozen rain stories preserved in crystalline archives. And hail, despite its violence, plays archivist too. When cut open, a stone reveals the alternating layers of supercooled water and ice it gathered. It's like a sky diary frozen in concentric circles, though admittedly one that might dent your car. The drizzle against your window feels tame compared to these extremes. Yet you realize all of them, sleet, hail, snow, rain, are siblings born of the same molecular family, shaped only by the temperature and turbulence of their descent. Tonight you're spared the icy percussion, but your thoughts drift upward, imagining the countless paths droplets might take. Rain may soothe, but its icy cousins remind you that the chemistry of precipitation can be playful, chaotic, even destructive. Each form tells the same story in a different accent, and together, they make up the language of storms. The rain outside feels ordinary to your senses, but in the hands of scientists, no drop is ever just ordinary. Imagine a laboratory filled with glass funnels and delicate sensors, each waiting to catch the sky. Rain collectors sit like open mouths, tilted upward, ready to trap the storm and carry it into flasks for study. Every storm becomes an experiment, every puddle a dataset. You picture a researcher, raincoat dripping, setting out simple cylindrical collectors in a field. The idea is straightforward: catch the water, seal it, and measure what's inside. The chemistry, though, is anything but simple. Back in the lab, technicians analyze the samples with mass spectrometers and chromatographs, teasing apart every ion, every gas, every unexpected hitchhiker. A single rainfall can reveal a fingerprint of the entire atmosphere it passed through. Historically, this wasn't always possible. In the 19th century, scientists relied on taste, smell, and rudimentary evaporation tests to judge rainwater's content. A quirky tidbit: some even boiled rain to dryness and weighed the residue, concluding with great seriousness that rain in industrial cities was heavier than rural rain. They weren't wrong, exactly. The pollution left behind told its own story. But today's instruments can detect contaminants in parts per trillion, uncovering chemistry those early pioneers couldn't have dreamed of. You lean closer to your window, imagining the drops racing down as test subjects. One might reveal nitrates from lightning, another sulfate from coal burning, another tiny fragment of pollen. Collectors capture them all, turning a storm into a chemical census. Scientists use these records to track far more than pollution. Rain analysis reveals patterns of desert dust crossing oceans, volcanic eruptions sending sulfur into the sky, even the faint traces of sea spray drifting inland. Some rainwater samples in Hawaii have shown particles from Asian dust storms thousands of miles away. It's proof that clouds are global travelers, stitching continents together molecule by molecule. Historians still argue whether the earliest systematic rain studies began in Europe or Asia. Some credit English chemist Robert Angus Smith in the 1850s. He's the one who coined acid rain. Others note that Japanese researchers had already been examining rainfall chemistry with surprising rigor. Either way, the practice became central to environmental science. And it hasn't stopped evolving. Modern rain collectors aren't just jars on rooftops. They're automated stations, often solar-powered, recording pH, ion concentrations, and even microbial content in real time. Satellites now supplement them, mapping rainfall chemistry from orbit. The sky is under constant surveillance, every drop logged, analyzed, and archived. You chuckle softly. Imagine explaining this to a medieval farmer who just wanted his wheat to grow. By the way, in the future we'll use lasers and orbiting machines to decode raindrops. He'd probably offer you an ale and politely change the subject. Still, you feel a kind of wonder. Tonight's drizzle sliding down your window could easily end up in a collector nearby. And months later, in a lab report, those very drops might appear as a neat row of numbers. pH 5.3, nitrate 2.1 milligrams per liter, sulfate trace To you, it's a calming soundtrack. To science, it's evidence, narrative, and clue. The storm outside has mellowed into mist, but your thoughts turn to storms yet to come. The ways rain is changing, the fingerprints of climate already etched into its chemistry. You can feel it in the uneven rhythms of seasons, in the downpours that seem heavier, in the droughts that last longer. Rain itself is shifting its script, and scientists are listening closely. One of the clearest signs lies in acidity. Thanks to cleaner energy policies, sulfur dioxide emissions have dropped in many regions, and acid rain has lessened. Lakes that once turned sterile are slowly recovering. But at the same time, nitrogen compounds from agriculture and industry remain stubborn, still seeping into the atmosphere and dissolving into raindrops. Historians still argue whether the late 20th century environmental treaties were a turning point of true progress, or whether they merely delayed more complicated crises now unfolding. You glance at the city street, imagining what's inside tonight's drizzle. It likely carries more ammonia than raindrops a century ago, blown from fertilizer use on distant farms. These invisible changes tweak the balance of nutrients, sometimes feeding ecosystems, sometimes unbalancing them. Rain no longer just mirrors the natural sky, it reflects human hands shaping the air. Another fingerprint is in the intensity. Warmer air holds more moisture, which means when storms break, they break harder. Scientists record rain bursts that dump inches in minutes, overwhelming drains and rivers. You've probably seen videos of city streets turned into rushing canals. The chemistry doesn't change in those moments, but the delivery system becomes overwhelming, reshaping landscapes faster than they can recover. A quirky tidbit: climatologists studying ancient tree rings and stalagmites have found evidence that rainfall patterns have shifted many times in the past, sometimes sparking collapses of civilizations. The Maya drought, the Akkadian Empire's decline each carries traces of skies gone fickle. Today, satellites and sensors give us warning, but the vulnerability is the same. We depend on rain, and rain doesn't always keep appointments. You sigh softly, because even as the drizzle soothes you now, you know the story isn't static. Some regions are already seeing acid rain fade into memory, while others face rainfall so polluted with modern chemicals that it corrodes steel faster than expected. And beyond chemistry, the pattern itself is shifting. Wet places getting wetter, dry places drier. Still, there's resilience in the cycle. Rain adjusts, carrying whatever the sky holds, delivering whatever the winds feed it. Tonight's storm is both ancient and modern, carrying nitrogen made by lightning just as it did for dinosaurs, but also carrying traces of plastics and fertilizers unique to our time. Each drop is history plus headline. You lean your forehead against the cool glass, listening to the last taps of mist against the pane. Climate change is not just a chart or statistic, it's in the chemistry of the droplets falling right now. And as the planet warms, those droplets will continue to tell the story, long after tonight's storm is gone. The drizzle dwindles now, each drop slower, softer, until the storm feels more like memory than presence. You stand by the window, watching the last bead streak downward and realize you've been following a cycle far older than yourself. Every molecule outside belongs to a loop that has repeated for billions of years, quiet, patient, unbroken. That drop sliding down the glass, it may once have been part of a Jurassic lake, lapped by the toes of a brachiosaurus. Another bead might have frozen in a glacier during the last ice age, only to melt centuries later and rise skyward as vapor. Water doesn't vanish, it just travels, reappearing in new disguises. Rain is simply one chapter in its endless autobiography. You imagine the cycle unfolding. Oceans release vapor, Clouds gather, droplets fall, rivers swell, groundwater seeps, and eventually the molecules return to sea again. The chemistry you've been tracing, ions, acids, nutrients, microbes, isn't a side note, it's the script of the planet's survival. Without it, there would be no soil fertility, no forests, no agriculture, no life at all. Cultures across time sense this, even without knowing the molecules. Ancient Vedic texts spoke of rain as the nectar of immortality. Greek philosophers called it the tears of the heavens. Historians still argue whether these metaphors were mere poetry or intuitive recognition of the water cycle's permanence. Either way, their reverence echoes your own quiet awe tonight. A quirky tidbit: NASA astronauts aboard the International Space Station drink recycled water that includes humidity from their own breath and sweat. In a way, they're living proof of the cycle on fast forward, sipping rain before it ever has the chance to fall. You grin at the thought: space-age rainwater harvesting in a tin can orbiting Earth. Back at your window, the last drops slide into silence. The street shimmers with puddles, mirrors of the sky now clearing. Tomorrow, the sun will coax much of that water back upward, invisible again, waiting for its next descent. And you, still damp from standing too close to the balcony, feel the comfort of continuity. The same molecules have rained on dinosaurs, on emperors, on poets, on you. Long after you're gone, they will keep falling, keep dissolving gases, keep nourishing soil, keep sculpting caves. The chemistry of rain is not just science, it's eternity in motion. So as you step back from the glass, the cycle continues outside, quiet and unstoppable. Tonight's rain is already preparing for tomorrow's sky, and tomorrow's rain will be the whisper of tonight, repeated forever.